I am in the last. All right. So welcome everybody to the Friday Happy Math Hour. Today in 1332, we're going to be talking about measurement, basic concepts of Euclidean geometry, perimeter, and area. And right away, we're going to start with an example. We're going to start by doing the typical US units of measurement, and then we're going to transition into the metric system, which is probably more popular than the English system. But in the first example, we have a conversion between 14 feet to yards. So we want to convert those 14 feet to yards. And what we need to make this conversion is we actually need our table, and the typical conversion that we have is that 12 inches is 1 foot, or 1 foot equals 12 inches. Also, 1 yard is equal to 3 feet, and maybe less common, 1 mile is equal to 5280 feet. So the one that we want to use for this example is the one relating the two units that we want to convert, feet and yards. So notice that would be the middle one. 1 yard equals 3 feet. And the easiest way to do this question, so there's actually several ways when you make conversions. There's some people that likes to use the so-called box method. And usually all you need to do is either multiply and divide. However, I find it easier when you're doing multiple conversions to use what I call the fraction method. And on the fraction method, you create a fraction, and on the top, you put the new units or the units that you want to have. So the units needed in the question. I want to convert it to yards, so those are my new units or the units needed. And on the bottom, I like to put the old units. So the conversion line is going to be coming to a fraction. You start by putting the yards on the top, the feet on the bottom, because those are the new ones and the old ones. And then you put the numbers next to it. So next to the yards, we have the 1, so we put the 1 on the top. Next to the feet, we have a 3, so we put the 3 on the bottom. And you multiply. This is a multiplication of a whole number times the fraction. And in these cases, you multiply the top 14 times 1 and then divide by 3. So it simplifies as 14 divided by 3. And this is an acceptable answer, by the way. I always remind my students in WebAssign, you only round when you are asked to do so. So if there's no rounding, it's better to enter the answer as 14 over 3. If it says round to the nearest tenth, then that would be like 1 digit. So the answer would be 4.7. If it says round to the nearest hundredth, then that would be 2 digits, which I put in here, 4.67. So just to keep that in mind when you're doing your homework, I do recommend that you look at the instructions. If there is no rounding rule and the decimal is an infinite decimal, like in this case, when you do this division in the calculator, you get 0.66666, it's better to leave the answer as a fraction rather than put it in decimal. We use decimals though to give us an idea. Like if the question was, what is exactly 14 over 3? Well, exactly that is, well, not exactly, but approximately, which is that symbol, that is about 4 yards and 0.67 of another one. Let's do another example. So now I'm going to convert 5 miles to feet. Similarly, the same table will help us. Now we're using the conversion line that has, so I always give my students these tables, and they're in charge to finding what is the line that they need to use. There's only 3 lines in here. And so I always mention, find the one that has the units that you're looking for. So miles and feet, that is the last one. And as before, the new units go on the top and the old units go on the bottom. The idea when you set up these fractions is that when you multiply, we think of the units as numbers themselves. So these miles multiplying cancel with the miles dividing. And so you end up getting only the new units, which is the feet. So once you have the units, next put the numbers. Notice that next to miles, we have a 1, so I put a 1. Next to feet, I have 5280, so I put it on the top. And then like before, this is a multiplication, 5 times 5280 divided by 1. The 1 is not really needed at this point, but you're going to see later how if you have a different number here, you have to do that extra division. So my final answer is that 5 miles is equal to 26,400 feet. Another something to remember is that when you're going from larger units to smaller ones, if you're going from larger to smaller, you're always going to multiply, because since miles is a bigger unit, it's a larger unit. When you put it into feet, you're gonna get a lot, like in the thousands, 26,000. So 5 miles is, and when you're going backwards, if you're going from a smaller to larger, then in these cases you're gonna divide. That's another way of remembering this. Kind of like checking your answer. It's always a good idea, even though you set up the fraction, even though you set up your operation, it's a good idea to keep in mind what are you expecting to have at the end. Do your answer make sense? Let's do another example. So on the next example, I have convert 3 pounds to ounces. So now these are in the previous ones were measures of length to measure distances. Now we're doing measures of weight. Pounds and ounces is something that we use to measure the weight of something. And so now our conversion table would be 16 ounces is equivalent to 1 pound. And I also have another line that says that 1 ton is equivalent to 2,000 pounds. For this question, we need the first line, huh? And again, the new units, I want to convert it into ounces, which is abbreviated OZ. Go on the top. The all units go on the bottom because this is going to cancel with that. And then I put the numbers next to each of the units. So next to pounds, I have a 1, so a 1 goes below. Next to ounces, I got 16, so 16 goes on the top. And this is another multiplication, 3 times 16 divided by 1. Notice that I didn't write down the 1, because anytime that you divide by 1, it gives you the same answer. And this is what I was saying. Most of the time, these conversions is either a multiplication or a division. So in this case, after simplifying, this becomes into 3 times 16, which is 48. So 3 pounds is equivalent to 48 ounces. Let's do another example. So now, so PT, this is the abbreviation for pints. So we're going to convert 18 pints to gallons. To make this conversion, we need now a different table. So now we're doing capacity. Capacity is a measure of liquid. So how much liquid you have in a container. And so the typical measurements are fluid ounces, which 8 ounces is equivalent to 1 cup. We also have 2 cups is equivalent to 1 pint. 2 pints is equivalent to 1 quarter, and 4 quarts is equivalent to 1 gallon. Notice that in this question, we don't have a conversion directly between pints and gallons. So we got to do it in steps. If I look at the pints, I could put it into cups and then cups to ounces, which is not what I want. But I could also use the third line to convert pints to a quart, and then the quarts, I could convert it into a gallon. So we could solve this question by doing 2 conversions, first into quarts and then into gallons. So the 18, I set it up, and then I multiply by the fraction. And again, the old units go on the bottom, and the new units go on the top. And looking at the numbers, notice that next to the quart, I have a 1, and next to the pine, I have a 2. So I put those numbers exactly in that position, the 2 next to the pines and the 1 next to the quart. And this now is going to be a division because it'll be 18 times 1, which is 18, over 2. And 18 over 2 is 9. So I get that 18 pints is equivalent to 9 quarts. Then I convert the quarts into gallons. Now I use the line below. I want to cancel the quarts, so I put the quarts on the bottom and I put the new units, which I wanted in gallons, I needed in gallons. I put it on top. So this, now it's going to be another division, 9 times 1, which is 9 over 4. So my answer is 9 quarters, 9 over 4 gallons. And if you divide this is equivalent to 2.25. The nice thing about this decimal is that in the calculator, you don't get more digits. We call this a terminating decimal. So if you have a terminating decimal, you could enter your answer either as a fraction or as a decimal. In this case, it is fine. Either or would be correct. Now, what you see below is actually the entire operation in a single multiplication. And this is the nice thing about using the fraction method, that you don't need to do 1 and 2 steps. You can do everything in a single step. So I would start with my 18 pints, and then I use the conversion line to cancel pints and put it into quarts. And then I want to cancel the quarts, so I put a new conversion line that has quarts on the bottom and the new units on top. And this becomes kind of like a multiplication of everything. So it'll be 18 times 1, which is just 18. And all of that divided by 2 times 4. And 2 times 4 is 8. And when you simplify 18 over 8, this is 9 over 4, which is exactly the same answer. So this is why this method, the fraction method, it's more efficient when you have multiple conversions. So if I wanted to continue converting this into liters, I can just add an extra. Or into fluent ounces, I can add more fractions and do all of this into a single operation, into a single step. Let's move on to the next question. So the next example is to convert. Now we're in the metric system. These are the units for the metric system. And students always ask me, especially my mechanics, and most of the students they're always using English units. They always wonder, like, where do we use the metric system? Well, the metric system is used all the time, especially most of the items that we have in our houses have both units. And for mechanics, I always like to point out, like, anytime that you purchase part of a car, most of the time you'll find the measurements in metric. In fact, that's the most common when you're buying a car. Like, most of the time, most of the units are in the metric system. So even though it seems like we don't need to concern about ourselves, it's always around us. So in this case, the M stands for meters, which is the unit of length, and we want to convert 3.07 meters to centimeters. So what we need is, of course, our conversion table. For the metric system, it's a little bit different. It has a very nice simplified prefixed notation. So these are words that you put, or prefixes that you put just before your unit. So kilo represent 1,000 of the unit. Hecto would be 100 of that unit. Deca is 10 times that unit. Deci is actually 1/10 of the unit. Centi is 1/100th of the unit, and milli is 1,000 of that unit. And so if I put the word meter right following kilo, 1 kilometer would be 1,000 meters. So these prefixes have a specific value of how many times. So whatever that number is how many times you need to multiply the unit. So it's 1,000 of that unit. And so obviously the reason why is this convenient is because later, instead of using meter, we're gonna use grams, or we're gonna use liters. So that's why it's very convenient to use the metric system. The conversion lines are pretty much similar, for not to say the same. All that it changes is the ending, because that represents the unit. So in this question, I want to find the line that compares a meter to centimeters. And this would be this one, the second to the last. It says 1 centimeter equals 0.01 of a meter. And so, like before, following the same process, the fraction method, you put the old units on the bottom, the new units on the top, because I want to convert from meters to centimeters. So the meters cancel, and my new units is going to be centimeters. And the ones, you could ignore the ones if you want to. Since the 0.01 is on the bottom of the fraction, this is going to be a division. It's going to be 3.07 over 0.01, which this is 307. So 3.07 meters is equivalent to 307 centimeters. Let's do another example. So as mentioned, now we're gonna do still in the metric system, but now we're doing weight. The unit of weight in the metric system is the gram. And in this case, we wanna convert 4.23 grams to milligrams. And let's look at the conversion. So I want to find the line that has those two units, grams and milligrams. Well, in this case is the last one. 1 milligram is equal to 1,000 of a gram. So I put my all units on the bottom of the fraction, so it cancels. And then I put the new units on the top. Then look up at the numbers that are next to the units. So the 0.001 goes here, and the 1 goes on the top, and that means I'm going to do another division. I'm going to divide 4.23 milligrams by 0.001, and this gives me 4,230 milligrams. So 4.23 grams is equivalent to 4,230 milligrams. Again, it still follows the same idea that I mentioned before, that when you go from a larger unit into a smaller one, when you go from larger to smaller, this is usually, in a sense, it is the way that I said it before, it might not make sense, but notice that the final conversion, I ended up getting a larger number. Let me keep it like that. So I was expecting to get something bigger than 4.23, and I did get it, 4,230. Okay, so the next example, I believe this is my last example for the conversion of metric. And now we are in capacity. Capacity is a measure of liquid, and in the metric system, that those are liters. So we want to convert 4 liters and 32 millimeters to liters. Now there's no and in here. This is kind of like, I call it a mixed unit, or a mix. It's kind of like a mixed number, like when you have 3 and A7s. So you have 4 liters in 1 unit plus 32 millimeters. So the idea is, since I want my final answer to be in liters, what I'm gonna do is I'm gonna convert everything into liters. So the 4 is already in liters. I only need to do the millimeters, the 32. And again, just like before, it basically is the same table, that every time I have kilo on the top, I have hecto on the top, deca, liter, deci, centi, and millimeter. And so this is actually not a conversion. This is just telling you that 1 liter is what the L represents, 1 liter. So the units that I need is millimeters to liters. That's at the bottom. And this time I want to cancel those millimeters. So I put the millimeters on the bottom so that this cancels with this. And I put the liters on top. Notice that because the liters are on top, you're going to put 0.001 on the top, and then you're going to multiply 32 times 0.001, which becomes 0.032. And now that is in liters, so 32 millimeters is equivalent to that. But since I had 4 liters initially, I add those 4 liters. So my final answer is 4.032 liters. So all of these in liters is 4.032 liters. Let's do another example. So now, of course, kind of like a necessary, obligated question is, can we convert between the English system and the metric system? And the answer is yes. I feel like these conversions are less known and less common, but we do have a table for that. And these are the conversions for units of length, units of weight, and units of capacity. So 1 inch is equivalent to 2.54 centimeters, 1 meter is equivalent to 3.28 feet, and so on. I'm not gonna read them all. Similarly, for weight, 1 ounce is equivalent to 28.35 grams, 1 pound is 454 grams, and so on. And 1 liter is equivalent to 0.06 quarts, and 1 gallon is 3.79 liters. So to answer this question, we need to find the one that relates miles and kilometers. That's actually at the end. The abbreviation for for miles is MI, because if you see the M by itself, that is meters. So not to be confused. And the conversion line is that 1 mile is approximately 1.61 kilometers. So using this conversion line, I put miles on the bottom so that they can cancel. I put kilometers on top. And since I put kilometers on top, I need to put next to it the 1.61. And this is going to indicate a multiplication, 55 times 1.61, which is 88.55 kilometers. So this is my answer. 55 miles is equivalent to 88 and a half kilometer. So miles are actually longer than kilometers. That's another conclusion that we can make from there. On the next example, now we're converting a rate, even though it doesn't look like. The question is, the price of gasoline is $3.89 per gallon. Well, I could also say $3.89 per gallon. So a rate is always a conversion between two numbers. Like in this case, it's telling you how much 1 gallon is worth. So when I see the units, I imagine that there's a one next to it. So 1 gallon is $3.89. The question is, find the cost per liter, round to the nearest tenth of a cent. If you still use exactly the same setup for making conversions, you would put the $3.89 on top. On the bottom of the fraction, you put the 1 gallon. And because you want to cancel the gallons, this time the gallons are on the bottom. So you need gallons to be on top. And I want to make a conversion into liter. So in my units, I'm going to look for something that relates gallons and liters. And where is this one? Right here. Units of capacity, because this is liquid. 1 gallon is approximately 3.79 liters. So I put the 1 next to the gallons. Why do the gallons need to be on the top? So that these cancels with that. As I mentioned, the idea when you set up these fractions is think of them as numbers. So you have a number that appears on the top and a number that appears on the bottom, those two cancel. It's like there's a number, you're multiplying and dividing by the same number, so the effect, they cancel each other, and there's no effect applying. So, and then the letters would go on the bottom. So the remaining numbers are 389, which is here, multiplied by 1, but the 1 doesn't change it. And then I have a 1 and a 379, so you can multiply those two. You get the same thing, 379. And this is now your conversion. Now it's going to be dollars per liter. Now, these, although it is correct, we usually want to have a 1 on the bottom. I want to know how much 1 liter is in dollars. Then what you do is you make this division, 3.89 over 3.79, and put the answer on the top. And the answer, now this looks like it might be rounded. And this is the case since the question is asking me to round to the nearest cent. So that's what I have. Only probably there's more digits after the 3. Like the answer is 1.03 and then a bunch of other digits. But I only want to have the answer with cents. So that's actually the the second digit. So my answer would be 1.03 divided by 1 liter. So 3.89 dollars per gallon is equivalent to $1.03 per liter. Let's do another example. In the next one, now we have to convert 90 kilometers per hour to miles per hour. So notice that I already have it in hours. So I only need to change kilometers to miles. In this case, so I set up the fraction. It already looks like this line effectively, it represents a fraction. So you put the 90 on top, the hours on the bottom. There's no 1, but you can add it there. And because I want to cancel the kilometers, then I'm going to put kilometers on the bottom. So these cancels with this. And then the new units, which is miles, go on the top. Now I look for the conversion line, which is right here. So 1 goes on the top next to the miles. 1.61 goes on the bottom next to the kilometers. And this indicates now a division, 90 over 1.61, which is 55.90 miles per hour. And rounded to the nearest hundredth, that would be 90. And more common, so you could actually, if you leave it, you could actually write it like this, 55.90 miles per hour, and you put the hour below or here. But the most common way of writing miles per hour is mph. So you could also type it in that way, 55.9 mph. Even though it says hundredth, since I got a 0 on the place of the hundredths, I could also just leave it at 55.9. Usually those zeros on the right, we don't write them after the decimal point. After the if I had 550, I need it, but if I have 22.9000, I don't need those zeros after the decimal point. So the 22.9 would be enough. Let's move on to the next. So we finally arrive to geometry. So in this lesson, we want to cover some of the concepts of geometry. And I started with some of the basic definitions. A point in mathematics is something that it's very simple. It's something that has no length, no width, and no thickness. So you cannot find the length, you cannot find a width, and you cannot find a thickness. So just a point. It doesn't count. It doesn't have a measurement in other ways. The next definition is a line. And similarly, a line has no thickness and extends indefinitely in both directions. So with the line, a line is actually infinite. And maybe half of a line, we call it a ray. It says that a ray extends indefinitely in one direction. So the picture that you see is actually the picture of a ray. And we know this because we see the arrow and it's only moving to the right. This dot signifies that it starts in there. It doesn't go to the left anymore. It starts right. It's kind of like the starting point. So I always like to think of rays as half of a line. And of course, the line would be in both directions. So it goes infinitely to the right and it goes infinitely to the left. And so those arrows many times they're not drawn. Like for example, if you have a graph such as a parabola, often we just draw it like that, but the parabola is infinite. It just keeps on going. So those arrows remind us that the line also extends. Like if I wanted to, it would not fit on this piece of paper because it just continues indefinitely. We could just say it just extends to infinity on both directions. So don't forget, this is very especially important when you're doing graphs because those graphs often we just see a piece of the graph, but often the graph is infinite. If we want to consider just a piece of the graph, we add those dots to indicate that it starts there and then maybe another dot where it would end. An example in geometry would be A, B, and C are all on a line L, on line L. So these represent points. We typically represent points by using capital letters. And then segments of line, a segment is actually something that has a beginning and an end. So a segment of a line has those two dots, starts there and it ends there. And so we have here the segment BC. In some books, they would put a line on top of it just so that you understand that that is a line segment. So the question says, given BC equals 16 feet and AB equals 1/4 of BC, find AC. So looking at our picture, we have all 3 points, ABC, on the line L. So that L represents the line. And BC is actually this portion. And we want to find what is the total length. Well, actually, if I could find AB, that would give me the answer. Because to find the total length, all I need to do is add AB plus BC. And that gives me the total length from A to C, which is what I'm looking for, find AC. So the first thing that we want to do is find AB by using that formula. We are told that AB is equal to 1/4 of BC. And if you substitute BC with 16, because that is the length of it, 1/4 of 16, that is actually 4. Or 16 divided by 4, that is 4. And so now that I know that AB is 4, then I just add it. To find the total length, add AB plus BC, which is 4 plus 16, and that gives me 20. So the total length is 20 feet. Next, we also want to do a review of angles. So an angle is formed by two rays with the same endpoint. So you can see here the two rays, and this is our endpoint. Or before I call it, that was my beginning point, but that is the point. And so this is one ray. So the rays are usually called the sides of the angle, and that intersecting point or that beginning point is the vertex. So each angle always has a vertex. Different type of angles, we have acute angles. Those are angles that measure less than 90 degrees. And I put a bunch of examples, and this is how I will represent them. So those ones that are less than 90 degrees, you could see them here. So we represent the opening right there. So that opening is the angle that we're measuring, and that's 40 degrees. And then this one is 45. So these are my two acute angles on the very top. To refer to this angle, often we use 3 letters by using points. So notice that the vertex always lies in the middle. So in this angle on the top right corner, I will refer to it as Q and then R and then S. So the vertex always lies in the middle. Similarly, this angle is acute, and to refer to it, I could use the letters L, M, N by putting the vertex in the middle. I could also have the initial and ending point. I can switch it. I could also write it as N, L, N, M, L. So starting here, going here, and going there. But the vertex is the one that is important. The vertex has to be there. And this little symbol, this little line that is here, that's the symbol for angle. So whenever you see that symbol, it refers to an angle. Now, a right angle is an angle that measures exactly 90 degrees. So angles of 90 degrees, they look like an L. They are perpendiculars to the sides. So usually we use a little bit of a square in here to represent. Often we don't write down the number 90, but when we see that square, we know that that's an angle of 90 degrees. And it kind of has the shape of an L, although in this case, it's like it's reflected, it's looking to the left. But it doesn't have to be, it could be in any position as long as the opening is 90 degrees, we call it a right angle. And the last category of angles are obtuse angles, and these are angles that are greater than 90. So we have 90, less than 90, and greater than 90. So an obtuse angle is usually less than 180. So examples would be 108, and that's the only one. This is an obtuse angle. It's more than 90 and less than 180. Notice to represent it, we can use GHI. And last, a straight angle is an angle of exactly 180 degrees. And this is it. It's can be confusing if you don't remember it. It can be confusing because basically a line, if you take points on a line, you get an angle of 180. So if you're here, this is my vertex and this is my one of my points and this is my other point. If you start from X to get to Z, you do like half of a circle. So half of a circle, which would be a line that creates 180 degrees. Now, the next two more names, we also have what we call complementary angles and supplementary angles. Complementary angles, they gotta add up, they sum 90 degrees. So for example, 30 and 60, if you add them, you get an angle of 90 degrees. You could see here that the sum of these two angles will give you 90. And there's lots of examples, say 10 and 80, those are complementary. 35 and 55, those two would be complementary. And there's infinitely many. The 30 and 60 is one of the most common ones, but anytime that two numbers, two angles add up to 90, then those are complementary angles. In a similar way, supplementary, now they need to add up to 180. So the example that you see in the picture would be 140 and 40. If you put them side by side, this is an angle of 140 degrees. And this is an angle of 40 degrees. So if you put them, if the second one starts where the first one ends, and you create a solid angle by adding both, the whole sum would be 180. So half of a circle, or the two angles, they fit on a line. And again, there's multiple examples. For example, 80 and 100. They add up to 180, 180, 90 and 90. Those two are also supplementary because the sum is exactly 180. Okay, so a question or an exercise concerning two angles would be this one. Given the angle, now often people will write down the word M, which means the measurement of the angle. So if they only put this, that refers to the angle, LOM. So this would be the angle. And if you want to refer to the value, like what is the measurement, then they put the M. So the measurement of this angle is 52. And then we also know that the measurement of LON, which is all of this, is 137. And the question is find the measure of the angle MON. So find these angles. So this is what we don't know. Well, we could see that if you add this plus this, that has to give you the 137. So of course the answer would be subtracting. So the entire angle is the sum of these two, this and this. So if you subtract 137 minus 52, you get 85, which is the measurement of this. So that was a simple, kind of like a warm-up. The next one, now, as soon as we throw in variables, the students right away usually get a little bit confused. And the deal with the variables is that variables represent numbers. So just think of them as numbers. So here I have this angle is represented with 3x. This angle is represented with 4x, and this angle is represented with 2x. The question is find the value of x. Well, notice that because the way the angles are set up, if you add them, you get a full line, which is a total of 180. So to answer this question, we can set up an equation. So the sum of these angles add up 180. So if you set up the equation 3x plus 4x plus 2x equals 180, then you can simplify on the left by adding 3 plus 4, which is 7, plus 2, 9. So all of this is equivalent to 9x. And then to solve for x, divide by 9 on both sides. And the 9 cancels, and x equals 180 over 9, which is 20. Now, another exercise would ask you, like, what is the value of each angle? Well, notice, and these are like typical questions. Sometimes they will ask you, what is the value of x? What is the x? Well, I already answered that. X is 20. So for this example, the answer is 20. But if the question was, what is the value of each angle, then I would go and substitute that 20. And so this angle is 3 times 20, which is 60. The 4x angle would be 4 times 20, which is 80. And the 2x, 2 times 20, which is 40. And you can check your answer that if you add 60 plus 80 plus 40, you get the whole 180. Okay, so let's move on to the next one. Now, there's a lot of angles. So the next type of angles sometimes are called opposite angles or vertical angles. And these are formed when two lines intersect. So another way to identify them is to say that they are across from each other on these lines. And they have the same measurement. We can just look at it in the picture. So for example, angle 2 has exactly the same measurement because it's exactly the same opening. It's like a mirror reflection. This is opening up and this is opening down. So angle 2 and 4, they're vertical angles and their measurement is the same. So if this is 150, then below has to be 150. In a similar way, angle 1 and angle 3 are also opposite angles or vertical angles. They're across each other. And so they also have the same measurement. The next type of angles are created when you have two parallel lines and one line that crosses both of those parallel lines. We usually call this a transversal line. Transversal. And observe that you create 8 different angles and they're represented with letters A, B, C, D, W, X, Y, and Z. Well, corresponding angles, they are in the same position. So focus on the points of intersection, this point. And on this picture, A, which is the top left, corresponds to the top left. So A is kind of like the corresponding angle on the bottom picture to W. It's exactly on the same location where W is. So they have exactly the same measurement. A and W have exactly the same measurement. Similarly, D and C, so this angle corresponds to this other one. So these two are corresponding and they have the same measure. And of course, the other two, B and X, so these corresponds to this, so those two have the same measurement. And C and Y, so these corresponds to this one. The next type of angles are called alternate interior and alternate exterior. And those angles are D and X. So these matches this other one. And the reason why we call them interior is because we think of the lines as being boundaries, and they are inside. They are inside the lines, in the interior of the lines. So these actually has the same measurement as that. So D is equal to X. Similarly, C is equal to W because they are alternate interior. Similarly, alternate exterior now would be A and Y. So now these are outside of the lines, on the outside of those lines. So that is A matches with Y and B matches with Z. So all of those angles, we're giving them a special name because they have the same measurement. An example involving a transversal line would be if you have parallel lines. By the way, this is the symbol for parallel lines. So when I read this, I would say, given that L1 is parallel to L2, find X. And notice that these are my two parallel lines, and I have this angle, which has a measurement of 2x, and this angle that has a measurement of x plus 66. So to find the value of x, I'm going to use those properties. Notice first that this angle, step one, this corresponds to this one. And what am I focused? I could also say that 2x corresponds to the top one. All I need to notice is that if I add this plus that, I get a full line, which is 180. So this is the same as this. So this is x plus 66 because they're corresponding. And then if you add them, these plus this, that's going to give you 180. So you end up getting the equation that 2x plus 66 is equal. Well, you can combine the x's. 2x plus x is 3x. And then this is like an equation that we can solve for x. So this would be move the 66 to the right by subtracting. Oh, I put this in the wrong place. So it's this one as well. It's 180 minus 66, which is 124. So you get the equation 3x equals 124. And to solve for x, divide by 3. And x equals, now I have a few mistakes here. This is also 114, not 144. So 180 minus 66 is 114. And when you divide by 3, this is 38. So I found the value of x, which is 38 degrees. Now, if I wanted to find what these angles measure, then I would substitute the x. 2 times x and x plus 66. All right. So the next question focus on a very common property of triangles. The sum of the measures of interior angles of a triangle is 180. So if you add, well, the example says find the measure of E, angle E, which is right here, when the measure of C is 35. So we know that this is 35 degrees. And something is missing here. If I recall, it was D. And D is equal to 105. So this is the one is 105. So I want to find the measure of A. Then the thing to notice here is that we have a triangle right here. So I'm going to use that idea. So first of all, notice that E and A are the same. So if I want to, because they are vertical angles, so if I want to find E, it's enough to find A. I put corresponding, but these are vertical angles, or opposite angles. Next, I know that D, this angle is 105. I can actually find B because if you add B plus D, you get 180. So 180 minus 105 would give you B, which is 75. And if you know B and if you know C, then you can use this property. The sum of A, B, and C has to be 180. So if I subtract 180 minus 75 minus 35, that actually gives me 70. So the angle A is 70, and also because E is vertical, then that angle is also has a measurement of 70. Okay, so we're getting to the end of the presentation. A couple more formulas to find the perimeter. The perimeter refers to the total length of a closed figure. So I want to add all of these sides. That's the perimeter, the total sum of all the sides. And I know that the length is 20 and the width is 30. So to find the perimeter, I would add length plus width plus length plus width. So that's one formula that you can use. You could also simplify it since the L appears twice. That would be like 2L plus 2W because there's two L's and two W's. And then you can factor the two and write the formula like this. 2 times L plus W. So if you substitute 20 and 30, this becomes 2 times 50, which is 100. So the perimeter of the rectangle is 100. Now, the next question says, find the length of fencing needed to surround a square corral that measures 60 feet on each side. Fencing is another word for perimeter because perimeter refers to the whole sum, and a fence usually is what encloses around an area. So using fencing refers that you want to find, when it says find the length of fencing, they're asking us to find the perimeter. Now, the nice thing about the square is that all of the sides are equal. So that's the difference between a rectangle and a square. A square is a special case of a rectangle. And if I add all the four sides, that's 4s, 4 times the same number. Since the side of one of them is 60, then the perimeter or the fencing would be 4 times 60, which is 240. The circumference, this is something that very easily gets confused. So the circumference is also a perimeter. So when we have a circle, the perimeter of the circle is called the circumference. So the circumference makes reference to the length of this line. Like if you could cut it with scissors, and you extend it into a line. So A starts here and then it goes all around. You get to B, which is the middle. So that would be in the middle. And then you get A at the end. If you could extend it, that is the length around the circle. That is what we call the circumference. And in this question, we know that the diameter is 99 kilometers. One of the formulas to find the circumference is equal to 2 times pi times the radius. Since we've given the diameter, the diameter is 2 radius. So in other words, the radius is half of a diameter. So divide 9 by 2. And in fact, I left it as a fraction. I substitute that into the formula. So it's 2 times pi times 9 over 2. These two multiplying cancels with that 2 dividing. And the only two numbers that multiplies pi and 9. So my circumference is 9 pi. Notice that we also have the instruction to give the exact measure. So do not multiply by pi. Usually pi is equivalent to 3.14 Some people add more digits, one, five, and there's more. Pi has infinitely many decimals. But don't multiply it. If you put this in a calculator, it'll give you an answer that has decimals, but that wouldn't be exact because it's an infinite decimal. So when you enter this in your homework, it's best to leave the pi symbol. So the circumference is 9 pi kilometers. Uh, the next formulas now are areas. Now, the perimeter is the length around it. The area is the space inside of it. What is the space inside of a rectangle? Well, this is a very common area, a very common formula. To find the area of a rectangle, you multiply length times width. Since the measurements are 308 and 192, usually the length is the longest side. So in my picture, I put 308 as the length and the width 192. And you multiply those two to find the area, which is 59,136. And because these are centimeters areas, the unit of area is centimeters squared. Now, often when you do this in WebAssign, you don't need to put the units. You just need to type the number. If we have a triangle, the formula to find the area of a triangle is base times height divided by 2. You can also write it as 1/2 of base times height. And in this question, the base is 18, which is the length on the bottom. The height, to identify the height, you need to have an angle of 90 degrees that comes from the opposite vertex onto that side. So not every line is a height. Make sure, in this case, the question already says, and the picture shows that it comes in an angle of 90 degrees. So you multiply 18 times 9, which is 162, and 1/2 of that is 81. And my last example, to find the area of a circle, this is the formula is pi times radius squared. Again, in this question, I'm given the diameter, so divide that by 2 first to find the radius. And the square, remember that the square is not multiplication by 2, it is multiply the number by itself. So it'll be 6 times 6, which is 36. And because I'm supposed to give the exact answer, I'm going to leave my answer as 36 pi. Do not multiply by pi. All right. So this is all for today. You'll have a good weekend. And I am going to give now the access to the host.
Thank you so much, Mr. Tintos, for presenting today. And thank you all for coming and being such a wonderful audience. And we definitely hope to see you soon again. So join us next week. And for math 1332, we'll be covering properties of triangles, volume, and surface area. And for math 2412, it will be the exam, the review for review 3. So hope to see you then, guys. Have an amazing weekend, and thank you all. Bye-bye.